When you're trying to change from standard notation to scientific notation, you should really just be thinking of two things. The first thing is, where should a decimal be? Okay, we're going to be moving the decimal. Where should it be? And the second thing is this number, is it a big number or is it a small number? Alright, let's take a look at our first example. Okay, we have, well, this is certainly a big number. Where should a decimal be? Well, the decimal should be after the first non-zero number. So 8.8. Now you don't have to include any of the zeros afterwards. Okay, so 8.8. Now it's going to be times 10 to the, if we're writing in scientific notation. And since this number is a big number, we're going to have an exponent that's going to be positive. Okay, but positive what? So since our decimal is going to be 8.8, I'm going to put a reference decimal right here and count how many decimal places it is going away from its original spot, which would be at the end of the number right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It moved 9 times, so this is going to be a positive 9. Because again, this is a big number. 8.8 times 10 to the 9 is also a big number. For example number 2, let's take a look at this. Where is the decimal place supposed to be? Well, it's supposed to be after the first non-zero number, so after the 1.5. And this is going to be times 10 to the something. Well, is this a big number or a small number? It's a decimal number, so it's a small number. So I know that this is going to be times 10 to the negative something. Alright, to the negative what though? So I'm going to put my reference decimal right here. And count how many spots it is away from the original decimal location. 1, 2, 3. Okay, so it's 3 that's supposed to go in exponent, but it is actually a negative 3 because, again, this is a small number. So it has to be 1.5 times 10 to the negative 3. Okay, so that's a small number as well. Alright, let's look at our next example, number 3. Okay, we're looking here. Where is our decimal supposed to be after the first non-zero number, which would be our 6? So I'm just gonna write 6. Okay, 6. And then you can write 6.0 if you wanted to, but I'm just gonna leave it at 6. Let's see. Times 10 to the something. Now, is this supposed to be a big number or a small number? It's a way small number. It's a really tiny decimal. So it's going to be times 10 to the negative something, alright? Negative what? I'm going to put my reference decimal right there and count how many spaces it is away from its original location. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be times 10 to the negative 12. Again, times 10 to the negative 12 because this is a really small number. So it's 6 times 10 to the negative 12. Excellent. Okay, we're going to look at now number 4. Okay, where is the decimal supposed to be? After the first non-zero digit, which would be 8. And since there is another number, non-zero number right there, we have to go 0.002. And then the zeros after that, you don't have to write down. So 8.002 times 10 to the something, right? And this is a big number, so times 10 to the positive something. Positive what though? Well, since the new decimal place is going to be right there, I'm going to put the reference decimal there. And since the old decimal place is right there, I'm going to put decimal right there. How many spaces is it away from the original location? 1, 2, 3, 4, 5, 6. So it's times 10 to the 6th power. Right? It's a positive exponent because this is a big number. 8.002 times 10 to the 6th. For the very last example we have here, where is a decimal supposed to be? After the first non-zero number. So it's going to be after the 9. Alright, and there is another non-zero number after the 9. Okay, it comes after 2 zeros, so we have to write that there. And now we do times 10 to the something. Times 10 to the what? Well, is this a big number or a small number? It's a decimal number, it's a small number. So it's going to be times 10 to the negative something. Okay, so now I'm going to figure out how many spaces it moved from its original location. So here's the reference decimal right here. Here's the original. How far away are they? 1, 2, 3. So it's going to be times 10 to the negative 3, since this is a small number. 9.003 times 10 to the negative 3. I hope you found this helpful.